Why do we name this our icon? So this is our name. So the I means innovative. Is you can see it's a brand new toy. We cannot buy it in the market now. And I means another intelligence. We hope it can do speech recognition. And then integration. As you can see, we put many techniques and put it on this car, so then it can work well. Okay. This is about the eye, and how about the car? The car will have mobility. We have this mobile power source, this battery, and a wireless instruction pass. So we can send the instruction through the. We don't have to connect something to that car, and we can control that. And secondly, controllability. On this machine, we put some relays, and the D to FPGA controls the relays, and the relays control current. Then the current controls the motors, and it can make some moves. Okay. This is our system diagram. You can see on your handout. Okay. So let's start the outline of this slide. First, I'm going to introduce our mechanical structure, include the batteries and motors. And secondly, the working principle, how we do this speech recognition. Okay. Here comes our mechanical structure. This picture is this car. Okay. First of all, this battery, it is a lead acid battery. It can produce 12 volts and 4 ampere hours. So much power. We have 12 volts power source. You can provide directly to the FPGA, and then the motors with wheel is here. And how does the motor works? If we want this car to go forward, we put both motors to turn forward. And if we want only a left turn, the right wheel goes forward and the left wheel stays still. Okay? So they can goes left, and the others they are similar principles. Yes. And then we use some relays to control the current, so the current can control the motors to let the motors to go to the direction we want it to turn. And how the relay circuit works. And okay, we put this small rectangle. This is a relay. So how the relay works? A relay has a if you give the relay a signal, if the signal has current large enough, then here is a switch. The switch will turn from 0 to 1. So and this current is provided from the GPIO port. And we test sometimes, and we find that two GPIO ports will provide enough current to make the relay to go from 0 to 1. And let's see first the relay 1 and relay 2. If this signal indicates zeros, then the batteries go from up and then down here. So the motors has a current from up to down current. And if this signal indicates an 1, so the current will go from down to the downside to the upside. So the motor will have an upward current. From this signal, we can have the motor turn forward or backward. Okay, then let's see relay 3 and relay 4. If we connect the both relay 3 and relay 4 are connected to the one side, then we see this only circuit. This is motor connect series with this smaller resistance, and then the motor will have a larger current, and we will go faster. If the only relay 3 or only relay 4 are connected to one side, if we connect to the 0 side, it is open circuit. The current will go from only one side, and from the basic circuit principle, two resistors connect parallel. It is a smaller resistor, and if you only connect only one, it is a larger resistor. Any questions so far? So from a relay 3 and relay 4, we have the motor go from a different current will go through the motor, and we'll have different speed. This is a closer picture of our wireless transmission module. So what does this module do? And if we want to send an instruction from this to wireless device, we have considered that the probability that a noise will occur. So our instruction contains 4 bits length, and if the noise is noisy, so we have an header to recognize that it is sending an instruction. So you really recognize this instruction. So let's go to a speech recognition part. Every time we say a word, we can have a plot of this time frequency distribution. The lower frequency and higher frequency, and from the time go from here to there. So every time it has a different frequency distribution. If we directly sees the data comes from the audio codec, we cannot recognize it directly. So we send this signal to different filter, and different filter if some filter has a low pass filter or some band pass filter and high pass filter. Because one voice connects different frequency part, so we hope to recognize from different frequency. The different frequency part have different amplitude. From the data data information we have in our class, the human ear listening frequency range is not uniformly distributed. We have in fact we have higher resolution and a lower frequency part. So we have we should have the filter like this. The lower frequency part has the higher resolution. This is how we want to do it. And this triangle filter, we make a digital filter, a second order bandpass filter to resemble the triangle shape. And for each instruction, we have its feed from the filter output. We have its feature, and every time we send, just like he did, he first record his instruction, and then when we are going to send a real instruction, he speaks, and his voice is compared to all of these instructions and find the most similar one. And the first phase, we record the original speech and search the sample with high energy and take the example. Take this sample for reference. And then when I was coming with first. May I have 1 more minute?
Okay.
If the energy is other than the potential, then we start comparing to each of the instruction we have stored in this area. We have some disadvantages. First of all, it's not stable, as we can see in the demonstration. And secondly, we can only compare to finite instructions that we have record in this memory. Also, some minor disadvantages. We don't have enough time to explain. This is our slide. Thanks for your attention. And thank you, judges.